Welcome back. Now we have defined the residue. We have looked at the formulas necessary for the calculation of the residue. We have stated the Cauchy residue theorem, which gives us an idea as to how we can evaluate integrals using the residue. Now let us go into the evaluation of those integrals. We are going to start with the indefinite integral, which is the integral on the curve itself, and we would see what it means when we restrict those poles within some certain contour or within some certain radius or region. Right? We are told to evaluate the integral of e raised by z divided by z minus 1 z plus 3 all squared dz, where absolute value of z is equal to 3 over 2. That's the first region, and then the second region is absolute value of z equal to 10. So we'll see what happens and which poles will qualify within this region. So let's go. As always, make sure to like, share, and subscribe, and turn on your notifications so you do not miss any of our videos. Now, the very first thing we do is to find our poles. So we would find the poles first. We'll set the denominator to 0 and we would evaluate as such. So from here, we can easily see that z equal to 1 is a pole of order 1, hence it's a simple pole. Then we have z equal to minus 3. This is a pole of order 2. Those are the two possible distinct poles we have, and their orders as necessary. Now for this pole, we have found that the next thing is for us to calculate the residue on both poles. We are going to calculate the residue on both poles first. Now, for the residue, we know the formula. In the case of the first pole, which is a simple pole that's equal to 1, we are simply going to have the limit as z tends to 1 of z minus 1 e raised to the power of z divided by z minus 1 z plus 3 squared. So from here, z minus 1 cancels out, and then we see that when we evaluate at 1, we're going to have e divided by 4 squared. We can write this as e divided by 16. This is going to be the residue at the simple pole 1. The next is to find the residue at the double pole, which is this. Now, we are going to quote ourselves the formula. So we have residue at z equal to minus 3. That is going to be 1 divided by 2 minus 1 factorial d dz, right? Of course, limit as z tends to minus 3. We have z plus 3 squared e raised to the power of z divided by z minus 1 z plus 3 squared, as the case is. Then z plus 3 squared cancels out, so we see that we have that the residue as f of z as z equal to minus 3 would simply be 1, because this is 1 divided by 1 factorial, that is 1. So we have limit as z tends to minus 3, and then we would have the differential of e raised to the power z divided by z minus 1. This would give us a quotient rule. I would evaluate as such. So you have limit as z tends to minus 3 of z minus 1 e raised to the power z minus e raised to the power z, right, divided by z minus 1 squared. And you can go ahead to just simply evaluate at minus 3. So we have this to be minus 4 e raised to the power minus 3 minus e raised to the power minus 3 divided by 16, which is minus 4 squared. From here, we would have this to be minus 5 over 16 e raised to the power minus 3. This would be the residue at z equals minus 3. So now we have the residue at 1, we have the residue at minus 3. The next thing is now to evaluate based off the regions that have been provided. Now for the first one, we have absolute value of z equal 3 over 2. This is the region, this is the contour for the first question. Now we have absolute value of z equal 3 over 2. This means that the radius is 3 over 2, and then whatever pole we are evaluating, the radius of that pole has to be less than 3 over 2, as the case is. Now let's see. Do we have points that fit that? Remember that our two poles is equal to 1 and then z equal to minus 3. For z equal to 1, the radius is 1. This is less than 3 over 2. This is good enough. For the second one, absolute value of z is equal to 3, that's the radius. We see that this is greater than 3 over 2. This will not fit into the region. So it means that for the region bounded by the radius 3 over 2, we would have that only the first pole will fit in, which means only the residue on the first pole will be used to find the integral. So what does that mean? The integral over c e raised to power z divided by z minus 1 z plus 3 squared dz in the first region would simply now be 2 pi I by the Cauchy residue theorem multiplied by the residue at z equal 1. So this would be 2 pi I multiplied by e divided by 16. And then from here, of course, this of course would simply be e pi I divided by 8 as the final result. So it means that the evaluation of the integral in the first region is going to be e pi I divided by 8. So this is very, very important to note. It means for questions like this, it is not just enough to find the residue and then just add both residues. You have to be very specific as regards to what region or what contour you are considering for the question. So this solves the first part of the question. Let's move on to the B part, which I'm sure you have also started evaluating on your end. Now, for absolute value of z equal to 10, what region will, what pole will qualify to be in it? Would it be one of the poles, would it be two of the poles, or the both poles, or would it be none of the poles? Make your choice and then let's proceed to see which it is. Now for absolute value of z equal 10, we see that z equal to 1 gives us the absolute value of z is equal to 1, which is less than 10. This qualifies. Then for z equal to minus 3, we see that absolute value of z, which is the radius, is equal to 3. This is also less than 10. So this qualifies as well. So it means both of them fall within the permissible region. So in this case, the integral of the function e raised to power z divided by z minus 1 z plus 3 squared the z would now simply be 2 pi I multiplied by the sum of the residues, which will be residue at z equal to 1 plus residue at z equal to minus 3, both 1. And then this would give us 2 pi I multiplied by e over 16 minus 5 over 16 e raised to power minus 3. This is the value of both residue. So e raised to power 16 is common, so we can have this as pi I over 8 e minus 5 e raised to power minus 3. We can of course go further to simplify this, take LCM, bring them all together if necessary, or you could decide to leave your answer like this. That will depend on how far you want to go or are willing to go towards getting your answer. So there we go. From here, you can easily see that when it comes to evaluating the indefinite integral, the priority, as always, is on where is the permissible region, or what contour do you need to consider? What are the poles? What is the order on the poles? What is the residue on those poles? And then, can you find the integral based off the regions and then utilizing the residues present or necessary? So this is what we have done as far as this question is concerned. I hope this is clear. And if you have any questions, let me know in the comments. If you have any observations, also let me know in the comments as well. As always, make sure to like, share, and subscribe, and turn on your notifications so you do not miss any of our videos.